This conference will now be recorded.
Hello, everybody. Jordan Girth here with the National Weather Service Office of Observations. Thank you for joining us for the Satellite Book Club Seminar Series. This is session number 172. Today is a book club on the road. Our Tower S team members, Kashad and Emily, are there on location at the Aberdeen, South Dakota forecast office. I'm joining you on a different assignment from Miami. A little bit different weather than this topic, but I'm excited for it. It's on the December 21 to 23, 2022 ground blizzard. Glad to have Steve Fleegel, the Science and Operations Officer at the Aberdeen, South Dakota Weather Forecast Office with us. And we have a great facilitator today, Carl Jones, meteorologist and satellite focal point at the National Weather Service Forecast Office in Grand Forks, North Dakota. Just a reminder that this will be the last Satellite Book Club of the year, calendar year, and the book club will resume on Thursday, January 11th at the normal time. Hope that everybody is planning a great holiday and able to take some time off. Certainly appreciate all the folks that are picking up extra shifts during the holidays. Just a few reminders before we get started that this session is being recorded. There will be an opportunity for Q&A after the presentation. Please post your questions in the chat and we'll field them in the order they are asked. We also encourage attendees to note their full name if you have not signed in with an account that uses your name. Perhaps you're signed in with an office account. And we're always looking for future presenters. Please contact our Tower S team, Kashad Bowman and Emily Maddox, if you would like to be part of our series as we head toward the 200th Satellite Book Club Seminar sometime in 2024. And if you're looking for training materials, Ross Van Til with the Office of the Chief Learning Officer can help you with that. I'd like to thank our Tower S team, Kashad and Emily, the Office of the Chief Learning Officer, the GOZAR and JPSS programs, our presenter, facilitator, and all of you for being with us today. Without further ado, let me introduce Steve, who's been the Science and Operations Officer at the National Weather Service Office in Aberdeen, South Dakota since 2016. He received his bachelor's in atmospheric science from the University of North Dakota and spent his several years after graduation working in weather modification, education, and climatology. Steve has been with the Weather Service for 18 years, and his previous offices include Green Bay, Wisconsin, and Marquette, Michigan. So you must like this cold, huh, Steve? All right, Steve, we'll turn it over to you.
Thank you. Yeah, thank you for having me. Unfortunately, my years in Marquette did kind of lessen my likeness of snow, but we still get some, at least occasional snow here. So I'm going to talk about our December 21st through 23rd, 2022 ground blizzard. Pretty significant difference from what we're seeing out here today. So quite the change from a year ago. So what happened during this event? We had pretty prolonged blizzard conditions, especially over the central and south central parts of South Dakota, where they experienced blizzard conditions for a solid 24 to some cases 30 or 36 hours. And those blizzard conditions led to pretty much many, or if not all, or much of the roads in South Dakota either being closed or no travel advised. And this included our I-29 corridor in the eastern part of the state, I-90 across the southern part of the state were closed for in some cases, well over a day or even into two to 3 days. But with it being a ground blizzard primarily, this did lead to some varying impacts. Those locations that were in rural areas, which is a good portion of South Dakota, we saw some pretty poor conditions. But if you went into the city, conditions weren't quite as bad. We had a little bit more of that sheltering that led to some lesser, more limited impacts, which also could influence or affect people's decisions, seeing in town that things are not quite as bad as what they were out in the rural areas. So just going to give you kind of a little bit of a weather overview with this. Here is kind of the WPC surface analysis. And so we had a low pressure system that developed and pushed its way into the Great Lakes region. So with that in place and a pretty strong high up to a 1056 millibar high out in Montana, we had this really good pressure gradient that developed and kind of gradually moved east across the area. In combination with that, our temperatures were really cold during this time frame. We had an Arctic cold front, which you can kind of see push across the area with time as this kind of loop comes through. Again, there's that Arctic cold front. And we actually had 5 straight days of at or below 0 temperatures in Aberdeen, leading right up into Christmas. So this slide just kind of showing more that both the spatial and temporal aspect to the stronger winds that we had across the area. And this is the 925 to 850 millibar RAB analysis for the winds. Just kind of highlighting that as we started on the 21st of December, things were focused more into the central part of the state. As we went through time and into the 22nd, things started to focus, a little farther east gradually through the day, with the winds coming up with, the 925 to 850 millibar winds in this area. We're in that 40 to 45 knot range. And then as we went into the 23rd, things started shifting off to the east of our area. So that'll be kind of things to focus on as we go into the satellite data as a little bit later on. So one thing I want to highlight here is just some of the factors that influence blowing snow. I'm not going to get into a whole lot of details. If you want to learn more about blowing snow, definitely check out the WDTD Walk Winter module on blowing snow. It was just updated this year and provides a really good detailed assessment on the blowing snow impacts and what can contribute to those impacts. But the big things that we always look for blowing snow are, what are the sustained wind speeds? What is the temperature that we're expecting? Because that can influence what strength of winds you need. The colder the temperatures, the less strong of winds that you need to produce significant blowing snow. And then also the snowfall rate and the snowfall age, whether it's snowing and how strong it's snowing will influence things, along with how old that snow is. So we generally want to have a fairly fresh snowpack to help allow that snow to blow around a lot easier. So for this event, we definitely had the snow on the ground, pretty significant snow depth across the area. As I mentioned at the beginning of the presentation, we were in the middle at this time last year, middle of a pretty significant snowstorm that dropped anywhere from 6 to a foot and a half of snow across much of the Dakotas, or at least especially the central and eastern part of the Dakotas. So anywhere that you're seeing any of the blues, you're well into 6 inches of snow on the ground, and then in the purple areas are over a foot to a foot and a half of snow on the ground. So we definitely had the snow on the ground. So then we just needed something to freshen that snow up, since it was about a week old or so. And fortunately, or I guess fortunately or unfortunately, depending on your situation, we did have some snow move through on the afternoon and evening hours of the 21st. That brought some light 1/2 inch to about 2 inches of snow across the area. So that helped kind of freshen up that snowpack and make it ready for the winds that were coming right behind the system. Temperature-wise, I already mentioned we were really cold. Leading up to and during this event, our temperatures really just hovered within 5 degrees plus or minus of 10 degrees below 0. So pretty cold situation. As I mentioned before, we can blow the snow around a lot easier when temperatures are colder, but this also created additional hazards as our wind chill values were well below 35 below 0, and I think at times even got to about 50 to 60 below 0 during this event. So anyone that did get stuck out in the blizzard conditions had essentially more hazardous weather to deal with, in addition to blowing snow, but the exposure to those long duration cold temperatures. So our really big challenge leading into this event was how strong those winds were going to be. We kind of had some conflicting signals on how strong they were going to be, and as I've mentioned a couple times, how cold the temperatures were really made a big difference, because a small change in those wind speeds really would influence what impacts we would see. And so we have a blowing snow model webpage where we can input temperatures, winds, snowfall rate, that type of stuff, and it will give us, based off of work from Tommy Grafenauer and Jeff Markowski, it'll give us probabilities of seeing a 1/2 mile visibility and how those relate to our impacts. And so you can see the color coding on the impacts. Essentially, as you get into the yellows, oranges, and reds and purples, it's increasing impacts from the event. And we can tie that into our headline. So generally, what we look for is things to be kind of in these orange values here, to be more of like advisory if we were going to issue like a winter weather advisory for blowing snow. Once we get into the red and the pink or purplish colors there, that's where we want to issue a blizzard warning. And so in this case, if we look at the wind speeds here at a 10 below temperature, if we go from 20 knots to 23 knots, just a 3 or 4 knot difference, that's going to make all the difference in the world, going from not really needing an advisory to needing an advisory. And you add another 3 or so knots on top of that, and you're well into the blizzard type criteria. So those just small changes in temperatures leads to great uncertainty on what the impacts are and how we can kind of message the scenarios from this event. And so I just want to show a little example here of the MBM forecast. This is for Pierre, South Dakota, that was created on December 21st at 1Z, just showing those differences in the wind forecast. So we had the operational MBM 4.0 at the time, which we knew had a little bit of a low bias, especially in situations like this. But if we look at where it was forecasting its winds, it was really kind of in this, maybe we'd get up to advisory level type impacts from this event, but overall things were going to be focused, kind of sub-blizzard in the 4.0 wind forecast. But if we look at the 4.1, we can see that it has that increase of 5 to 7 knots, which really kind of transitions us right up into that, likely seeing blizzard conditions during this event. So we were looking at both of this data and kind of, trending or adjusting our forecast to match up with our expectations based off of everything we were seeing. And this, kind of trend or difference between the experimental 4.1 at the time and the 4.0 MBM winds was consistent as you went farther east and northeast with time. It's just the values were a little lower because the winds were a little weaker up in those areas. So overall, which performed best out of all that information? It really was the MBM 4.1 over the central part of the state. That tended to do the best on the winds in there, where we had that really strong 4 winds aloft. As we went into the James River Valley, which includes the Aberdeen area, that area, kind of a blend of the two, tended to perform best. And then as we went farther along and farther to the northeast, the MBM 4.0 ended up doing the best in that area. So now we're going to kind of get into the cool or the fun stuff with the satellite data from this event. And before we jump into the satellite data, I just want to highlight the images that we're going to be using here over the next several slides is really looking at the experimental Blowing Snow RGB. And this RGB was developed by Bill Line with his collaboration and discussion with Carl Jones, who's our facilitator today, which is awesome to have Carl on here to kind of provide his feedback. But found that we were a lot of times using the day's snow fog RGB to help identify and detect blowing snow, but we wanted to get a little more detail they wanted to get a little more detail on that blowing snow. And so they swapped the veggie band with your red visible band to help get that increased resolution, and then made channel adjustments to help bring out or tease out that blowing snow a little bit better. And you can see a really good example of this back from 2019 in the Grand Forks area, where if you look at the day snow fog RGB, you can see the blowing snow there. You're not maybe picking out some of the details with some of the horizontal convective rolls that were going on. And where you look at the day blowing snow RGB, you can really see a lot more details on that blowing snow around the Grand Forks area with this event. So I'm going to use this blowing snow RGB for the next, several slides as we go through. And so I've got a loop here of the December 22nd, 2022, essentially the daytime. So we're starting at the early part of the day, continuing through the afternoon hours, and then you kind of get to the evening time frame. So this is zoomed in on central part of South Dakota and eastern parts of South Dakota. So essentially the Aberdeen forecast area. Some of the things I want to point out, you can see here right in the latter part of the loop, you really started to see these horizontal convective rolls develop through the afternoon hours as those winds really started to pick up through the day on the 22nd. So I thought that was really neat and really allows us to pick up that detail. The other thing for this event, we have Lake Oahe here over to the northwest of Pierre. That was open at the time. So we had this really cold air moving across the warm waters of Lake Oahe. So we were getting lake effect snow bands, which we never saw on radar because we were overshooting it, but we were able to pick that up on satellite. And that was going right into Pierre, the capital of South Dakota, and help contribute to those 30 to 36 hours of blizzard conditions that were ongoing in Pierre. And then farther eastward, the red areas, that's where snow is on the ground. So you're seeing that snow on the ground, but you can see as we go through the day here, you can see that blowing snow really start to develop over the eastern part of South Dakota. And so, it just helps give you that context of, what's actually going on with the blowing snow when we're looking at this as forecasters and, using it to help update and understand what's going on out in the, outside the office here. So if I go to the next couple slides, these I'm just going to kind of walk through. We have the satellite data where we can see what's going on from above. We have the observations at ASOSs and AWOSs, but here in South Dakota and in a lot of areas, we have limitations on the coverage of those ASOSs and AWOSs. So here in Aberdeen, we utilize the webcams a ton to help fill in those gaps of what's going on in between the ASOS observations. And so I'm going to step through several locations across the area. There's a couple of forecasters that work together to help develop visibility kind of guides for us on a clear weather day. They use Google Earth and kind of help map out what each location is on these webcams, so we can use that in real time to understand what the visibility is at each one of these locations. So based off of those graphics that they created, we were able to determine that it was essentially about 1/10 of a mile here in Trail City, South Dakota. As we go forward in time, now we're down on Interstate 90. This is Myrtle. Interstate 90 is closed out. Filling in those gaps, you can really see visibility is poor in that location. We go over to Pierre, or at least northeast of Pierre in Blunt, South Dakota. Not quite as bad in this location. They're missing out on that blowing or that lake effect snow that I mentioned earlier that was occurring there. So while the ASOS was reporting 1/4 mile visibility was a little bit better up in Blunt, South Dakota. We move up kind of this no man's land of our observations in METAR and or essentially ASOS observations in Miranda, South Dakota. So conditions were really poor there, well into blizzard conditions. We start moving a little farther east, and conditions, the winds are still trying to pick up at this time. This is at 18Z on the 22nd. So we're starting to see a little more red that's still ongoing in parts of the eastern part of the area. So visibility wasn't quite as poor in that location. As we move farther to the east, we're also seeing a little less of some of that lofted blowing snow that's in place. And so we've got, you can actually see the sun or the sunlight here on the webcams there. And if we move farther to the east in Millbank, South Dakota, where we're not really picking up much in the blowing snow RGB, we definitely have, conditions that are much improved on the webcams there. I will take a step back here. We'll zoom out a little bit and just look at the regional view, because while we were seeing blowing snow in the Aberdeen forecast area, it wasn't just us that was seeing widespread blowing snow from this event. We had it stretched from eastern Montana, western Dakotas, all the way down, and you can even see as we get later on here, you can see these horizontal convective rolls, kind of cumulus type fields that develop from that blowing snow all the way into the Nebraska. And I will point out, you can see there's maybe a little less of the redness in this area, so there's less snow cover in this area, and so their visibility wasn't as low as it was and elsewhere up farther to the northwest where we had that snow on the ground. And you can see that here, if I can get to the next slide, where you can kind of see that highlight. So down in that area where they didn't have as much snow on the ground, the visibilities were a little higher because we weren't re-lofting that snow from the ground to reduce the visibilities. And then you go farther to the north and west, right in that same area, it just kind of helps reinforce what you're seeing on satellite with what the observations are showing from this event. So now we'll zoom back into the Aberdeen CWA and move a day ahead. So now we're on December 23rd. This is, the winds, if you remember back from that 925 to 850 millibar wind speed, the strongest winds were shifting over the eastern part of the state and more into Minnesota and Iowa at this time. So we had, if we look at, the central part of the state through the day, really not too much going on. It doesn't look that impressive. If we look really closely, and hopefully you can kind of pick it out on the webinar here, but there's these little filaments of some blowing snow that are occurring kind of in this part of South Dakota, right in the middle part of the image. And that helped, we were able to use this in real time and help us understand in combination with our webcams that, yeah, we are still seeing some blizzard conditions on in this case, and we want to hold on to that that blizzard warning a little bit longer. And then especially as we get into the eastern part of the state, you can see that pretty extensive blowing snow. This is the Prairie Coteau, so we're kind of, I know you always think of most of South Dakota being flat, but we do have some elevation here in the eastern part of the state. And this is always kind of a troublesome area for us because of that elevation influence, and you can see the blowing snow ongoing in that area. So we'll kind of jump back into look at the webcams again, and again, just reinforcing the need to be able to look at those webcams in concert with the satellite data and the observations. You can see here where Mobridge really wasn't showing much impacts, but if you go a little bit of west Mobridge, even though the satellite really isn't showing much in this area, with that red showing just essentially the snow on the ground, we were still seeing some reduced visibilities from blowing snow in that area. We go down to Murdo, this is on I-90. Conditions were improving, just a little bit of drifting snow, so that matches up with essentially the observations that we're seeing in the area. Over in Pierre, they were still 2.5 mile visibility at this time, but Blunt, just a little bit to the northeast, they were 6 miles. And that's due to that lake effect snow that was kind of still ongoing off of Lake Oahe, which you can actually now see that was out there. And so you can see that on the webcam, just way out in the distance, maybe a little tough to see, but you can see those lake effect clouds that are ongoing there. Now we move into the central part, and I mentioned this a little earlier, where we had this low filament of some blowing snow. It just reinforces that. Yes, we're seeing blowing snow, and two, it's reducing conditions down to blizzard level there in Miranda, and so that can help build your confidence that we're seeing all along these areas, to the north where we've got some blowing snow, and to the south we're probably seeing or continuing to see blizzard conditions in those locations. We'll just kind of continue moving eastward into Andover, and then into Summit. Now we've got pretty poor conditions in Summit, well below a quarter mile. This is on Interstate 29. Interstate 29 was still closed at this time. And then as we even move over to Millbank, it's vastly different than what we saw on the previous time when we were in Millbank, where conditions were pretty nice. Now the visibility is a lot worse. So, as I mentioned, we were using this in real time. The forecaster here in Aberdeen even mentioned in his forecast discussion, talking about how he used that blowing snow RGB to help indicate that blowing snow is kind of coming to an end in the James River Valley. But, with what he was seeing with the extent of the blowing snow over our area, and the winds expected to continue into the evening, would continue to keep that blizzard warning going in the eastern South Dakota and west central Minnesota as we went into the evening hours. And then finally, I want to thank Carl Jones for his sharing of this loop. This isn't something that just impacted the Aberdeen or even just the northern plains itself. This blowing snow behind this Arctic cold front really impacted all the way through and into the Ohio River Valley. Carl had mentioned even Pennsylvania and Tennessee had reports of blowing snow from this event. And so it just shows that the blowing snow RGB can really be useful for much of the northern part of the U.S. You don't have to be in the northern plains to be able to use this RGB. It can help you understand the extent of the blowing snow from an event. So lastly, just some summary slides here as I loop this. This is a truck that got stuck by one of the DOT webcams there. So you can kind of see how conditions evolved through this event. But really prolonged blizzard conditions led to some significant impacts across all of South Dakota. And our satellite use of the satellite data, especially the blowing snow RGB, really helped us understand the aerial extent of the blowing snow that was ongoing during this event. But just keep in mind, you really have to combine what you're seeing on satellite with what's going on webcams, observations, spotters, emergency managers, all that type of stuff to understand the full extent of the impacts from an event. So with that, I do have a few links. I'm not sure if this will be available, but I've got links to our event summary page, blowing snow model page, and some satellite liaison blogs that have been done on the blowing snow RGB. So I think that's everything I have.
Okay, thank you so much for that presentation, Steve, as well as Jordan and the rest of the Towers S team for setting up this long-running satellite book club. So before we get into the discussion portion of this satellite book club session, I encourage attendees to stay on for the discussion, especially those within the field offices and regional headquarters. When asking a question, please specify your full name in the chat or introduce yourself when asking a question live. Additionally, I encourage attendees to complete the feedback survey that will be posted in the chat room of this session. As previously stated, the beginning of this session, the Satellite Book Club will resume on January 11th, 2024. So we look forward to seeing everyone back for the first session of the new year on that date. And lastly, I encourage attendees to contact the Towers S team, that's Kashad Bowman and Emily Maddox, for questions about the Satellite Book Club or for configuration of satellite products. All right, so now we can get into the discussion portion of this session. And right out of the gate, I was wondering, Steve, if you knew where we would be able to find this experimental blowing snow RGB that you just showcased for us? And is this a part of the Towers S install?
Yeah, great question. Yeah, right now I think it's just more focused on offices that kind of have sought out it, and so we were able to get it here in Aberdeen. I think you have it up there in Grand Forks and several of us in the Northern Plains. So if you do have any interest in it, feel free to reach out to myself or Carl. We'll be able to help you get that set up. Right now, it's not included in the Tower S, so if people are interested in it, definitely reach out to us, and if there's something that we would have greater interest, it'd be awesome if it's something we could roll into the Tower S, RGBs at some point in the future.
Yep, yeah, that would be really great to see this get out of the experimental phase and then potentially into the operational side of things. I know just from our personal experience, we've had a lot of use of this RGB in the wintertime. I mean, I guess it kind of makes sense. But as you had shown earlier, just the spatial extent as to how far this reach can be, it could potentially be useful for numerous offices, like you mentioned, just in the northern portions of the United States. And it looks like we have a question from Bill Soberg. I was curious if you had looked at the Veers Blowing Snow product, or maybe even the day-night band during this event, or whether it's during the day or at night. Mentioning that day-night band.
Yeah, great question. Unfortunately for me, I didn't look at any of that. I was actually on the morning of the 21st or 22nd, I was booking it out of Aberdeen to get out of town before the winds really picked up. So, I had to kind of get a lot of these images after the fact and that type of thing. So I didn't look at any of the Veers stuff either at nighttime or during the daytime.
Yeah, I can't recall if I did either for this particular event. And yeah, the spatial extent of this Blowing Snow event, it would be, I think, pretty interesting to look at the day-night band to see if we can pick out these roles, that satellite signature that's kind of correlated with blowing snow at night. I know that's one thing that our office continues to struggle with in terms of at least, identifying at least on satellite where blowing snow, the spatial extent of blowing snow is. So it might be interesting to look at that.
Yeah, exactly. I think that's really the difficulty at this point. We've got a really good product that helps us during the daytime, but at night we're kind of back to just what we have for observations. Webcams even at night are pretty tough to be able to tell what the visibility is. You can maybe tease something out every once in a while, but if we could kind of come up with something that helps us out during the nighttime via satellite, would be a huge help.
Yeah. Yeah, and kind of speaking of just continuing the Blowing Snow RGB itself, within the RGB, do you need to make any adjustments within this particular RGB, the Blowing Snow RGB, to make the Blowing Snow stand out more? Have you found yourself adjusting away from default settings to continue to tease out those Blowing Snow signatures?
Yeah, great question. Myself, I generally just use the default values. I think they work pretty well. Haven't really run into too many issues. I know one of our kind of main satellite guys in the office, he'll kind of tease out or adjust it a little bit to kind of pick up things maybe a little bit earlier in the morning, just allow us to see it maybe just by like a half an hour earlier than what we can traditionally do. But usually, yeah, what the RGB has given us, I generally run with it. So.
Yeah, I would agree with our experience as well. The current settings, the way it's tuned, is pretty sensitive in the visible and near infrared. I want to say it's both, but I know it's at least the visible channel, that red channel, to really compensate for the lack of solar reflection that northern reaches typically experience. Northern reaches of the CONUS and Alaska, I suppose, just within the winter time. So as it stands right now, I think the tuning of this particular RGB is pretty well suited for at least, I don't know, the Dakotas. You know, I would be interested to hear if anybody else has seen or used this particular blowing snow RGB further south, if that's the case. We actually have some comments from Scott Lindstrom, kind of referring back to that day-night band. If we had looked at day-night band at nighttime during this particular event, and lo and behold, it was a new moon that had December 23rd, 2022. So probably was not going to get much information from moon, the reflected light to tease out those particular signatures in this case. But so that is something to keep in mind when looking at the day-night band. And if you are relying on that visibility kind of component, kind of needs some light to shine upon from the moon. Yep, and I was also going to give you some kudos at least for kind of correlating those surface conditions with the satellite RGB by looking at the webcams and looking at the visibility reductions from surface observations. You know, it really underlines, I think, you know, you kind of coined the phrase that that whole observational approach that is needed to assess the impacts from blowing snow. You know, with this particular satellite, you know, it alone cannot tell you just how reduced visibilities are within the satellite signatures. And but yeah, I just wanted to give you some kudos on you know, continuing to utilize the webcams and other verifying that what the impacts could be. And I had noticed, I don't know if you can go back to the loop where it showed, I think it was one of your first loops of the blowing snow RGB that kind of showed, I think it was Nebraska. You had mentioned how they had a little bit of a lack of snow cover, and then it was less red in that particular area. Maybe it was more of maybe the regional loop. So in the RGB, is the satellite color highlighting the blowing snow the same as snow sitting still on the ground?
No, generally it's not. So the snow sitting still on the ground, it would be kind of your red highlights that you can see there. You know, especially kind of focused in, like if we look at Minnesota, for example, you can see earlier on in this loop, it's pretty red. So that would be that traditional snow sitting on the ground. And then as it starts to get lofted and it kind of gets more of that orangish type color, orangish hue, which you can see across the central part of South Dakota, and kind of really focusing into Nebraska in that area. So, you know, that really helps us understand, okay, this is, you know, blowing snow that's getting lofted versus the snow on the ground. Now, Carl, I think you had done some work into that in one of your papers, right, that you had did with Aaron Kennedy. I don't know if you had any details, additional details on the reason why you see those color differences.
Yep. Yeah. So just really quick, the composition of the RGB, it's not only utilizing that visible information from the red channel. Oh, hey, honey, thank you. But additionally, it is taking information from the near infrared as well as a difference between shortwave and long wave information. So it's that near information, that near infrared information that's providing those color differences that is helping differentiate the snow standing still on the ground, as well as you know, the snow that's being lofted. So it's a slight color variation, but it's a result of those near infrared and other infrared channels. And it looks like the Twin Cities, National Weather Service Twin Cities, has a quick question. So feel free to unmute yourself if you want.
Sure. This is Jake from the Twin Cities. Can you hear me all right?
Yep.
Okay. So we recently did an IWT for this event. It was long duration, like you mentioned, and the wind chills were so cold. We were like -30, -40. And so we used the word life-threatening, and we wanted to get our partners' take on that. And they absolutely agreed with it. They said the blizzard conditions by themselves weren't, but the fact that if you got stuck or had car trouble or anything like that, you were in a life-threatening situation. So maybe this is included already, but just hearing that feedback, and that's why I really wanted to tune into this presentation. Is there a way to maybe do a real-time composite blizzard severity index where maybe you take some of the RGB, and I don't know if you could combine it with IR to maybe get like a temperature feel where it's clear, but maybe just a quick way to kind of show blizzard severity based on this event and the feedback we got. Just an idea.
Yeah, thank you for that. Yeah, that was one of the things, I know that was really leading into, our event too, which, just the intensity of those wind chills, it was bad. If you got stuck, it was not a good situation. So, I think it would be interesting to be able to kind of tie some of that type of stuff in to really help out with our messaging on these events of how, like you said, how life-threatening this event was due to how cold it was across the area. Even myself, we snuck out of Aberdeen heading to Minnesota, on the early in the 22nd, and I remember thinking to myself, it's like, are we kind of almost a little silly doing this? Because if we do go off the road, you're going to be stuck for a while, type of thing. So yeah, it's definitely something that definitely want to continue to look into and really message those impacts.
And thanks, Stephen, for helping answer that. Kind of going back to the difference in the colors between the snow on the ground and blowing snow lofted. Mike Stavish kind of referred, the difference between in coloring, difference between areas in northeastern Colorado versus, say, central South Dakota. And at least just within this RGB, it almost kind of looks like maybe similar to what's happening in Nebraska, where there might be a little bit less snow on the ground, as we're starting to see a little bit more kind of greenish color. And maybe in this particular view, and just being so far zoomed out, the differences in color between the lack of snow on the ground versus the blowing snow on the ground, or the blowing snow lofted, it might not be as noticeable, but if you were to zoom in, it should be quite apparent, not only just in the difference of color, but also when you loop this, you should be able to see those moving horizontal convective rolls that are associated with the blowing snow.
Hey, Carl.
Yeah, go ahead.
This is Mike. I just wanted to comment. I'm at northeastern Wyoming there. In other words, it looks like is it just stratus in northeastern Wyoming or low stratus versus blowing snow in central South Dakota? That's what I was trying to delineate there. The similar colors between the two, they just kind of look the same, but are we looking at blowing snow in South Dakota and maybe mainly stratus in northeastern Wyoming? Is that what's going on there?
Are you talking like up by the Black Hills area or west of the Black Hills?
West of there, yeah.
That's a good question. I'm kind of having a tough time teasing it out on that, at least from what I'm seeing here. But yeah, I'm not sure offhand. If it might just be more on the stratus side of things.
I was thinking when you're using that RGB, is there sort of a requirement to identify motion in the low cloud and blowing snow features to sort of verify that you are looking at blowing snow versus not? Just curious.
Yeah, usually you'll be able, when you zoom in, like Carl was kind of mentioning, when you zoom in, you're able to see some of that motion aspect. And I know for us too, this was kind of an interesting event because, and I kind of wonder if it's due to how cold conditions were during this setup. But even in South Dakota, it was tough at times to really be able to pick out that actual pure blowing snow, or what maybe is some of that blowing snow getting lofted, because it's not, a lot of times it wasn't showing up like we traditionally see as that loops on kind of ongoing, where you have some of those more of that whiter, bluer color to some of the stratus like we normally would want to see. So I'm kind of curious if maybe that would be part of why we're not maybe seeing that as well, or that delineation as well between the two areas, just because of the coldness aspect. But that's just potential theory without looking at it a little closer.
Thanks for that.
All right. Thank you, Mike, for the questions, and everybody else for the questions. We do have to end it right now, and I will pass it back to Jordan for final comments.
All right, thank you so much, everybody. Thank you so much, Steve, for that presentation, and Carl for doing the facilitation, and thanks to Keshad and Emily for being on site today. Thanks to everybody for the great discussion on this particular topic and throughout the year. If you need to get in touch with the Tower S team related to the Satellite Book Club or the configuration of satellite products, the email addresses for Keshad and Emily are there on the screen. You can also find them on the Tower S Slack channel. Just as a reminder, we will be taking a break from the Satellite Book Club until 2024. So hope everybody has a happy holidays and a good start to the new year. Thank you for joining us throughout the year, and we will see everybody on Thursday, January 11th. Take care, everybody. Bye-bye.